థర్మోడైనమిక్స్ ఏంటంటే వర్క్ అండ్ హీట్, ద రిలేషన్ విత్ హీట్ అండ్ వర్క్, అదర్ ఫార్మ్ ఆఫ్ ఎనర్జీ, మ్యాక్రోస్కోపిక్ అండ్ మైక్రోస్కోపిక్ అప్రోచ్ ఆర్ దే, థర్మోడైనమిక్ సిస్టమ్స్ ఆర్ దే, థర్మోడైనమిక్స్ ప్రాపర్టీస్ ఒకటి. సో అదేవిధంగా ఇక్కడ ఏంటంటే రివర్సిబుల్ ప్రాసెస్ అండ్ సైక్లిక్ ప్రాసెస్, క్వాజిస్టాటిక్ ప్రాసెస్, from equilibrium state only infinitely every instant. Adiabatic process in which there is no flow heat between a system and surroundings. Zeroth law of thermodynamics states that when the two bodies are in thermal equilibrium, the third body they are also thermal equilibrium. And PV is equal MRT, gas standard, volume meter cube, temperature ఒకటి, gas constant Newton meter for kg Kelvin. అది according to van der Waals following the empirical equation P plus A by V square, V minus V is equal to RT. Compressible fluid Z is equal PV by RT. First law of thermodynamic JQ minus W. ఇందులో J is equal 4.186 joules per calories. అదేవిధంగా వర్క్, quasi-static process, work done can be expressed W equal to integral of V1 V2 PdV. Work done in free expansion is 0, T1 T2 to CdT. Work done in isothermal process MB MRT log of V2 by V1, and adiabatic expansion MCV T1 minus T2. క్వాజిస్టాటిక్, ఐసోథర్మల్, క్వాజిస్టాటిక్ ఈ విధంగా Q minus Q2 equal W ఈ విధంగా వస్తుంది. Efficiency of heat engine work output by input Q W by Q, Q1 minus Q2 by Q1 ఈ విధంగా వస్తుంది. T1 minus T2 by T1, enthalpy H equal U plus PV. Corner refrigerator which coefficient of performance T2 by T1 minus T2, enthalpy H equal U plus PV. Specific enthalpy H equal U plus PV small. Heat వచ్చేసి ఇది స్పెసిఫిక్ హీట్. స్పెసిఫిక్ హీట్ కెపాసిటీ ఎట్ కాన్స్టెంట్ ప్రెజర్ వచ్చి డో హెచ్ బై డో టీ పీ వస్తుంది. స్పెసిఫిక్ హీట్ కెపాసిటీ కాన్స్టెంట్ బై డో యూ బై డో టీ ఇటు వి వస్తుంది. ఫర్ అట్మాస్ఫియర్ ఎయిర్ సిపి సివి 0.24 and 0.171 రెస్పెక్టివ్లీ. ఫర్దర్ సిపి మైనస్ సివి ఈక్వల్ ఆర్ బై జే, సిపి బై సివి ఈక్వల్ గామా 1.4. ఎనర్జీ ఈక్వేషన్ ఫర్ స్టడీ ఫ్లో వచ్చేసి ఎంథాల్పీ P1 ప్లస్ KE1 మైనస్ ఎంథాల్పీ PE2 ప్లస్ KE2 మైనస్ వర్క్ ప్లస్ హీట్ ఈక్వల్ 0. సెకండ్ లా ఆఫ్ థర్మోడైనమిక్స్ వచ్చేసి ఈ విధంగా ఉంటుంది. కెల్విన్ ప్లాంక్ స్టేట్మెంట్ అండ్ క్లాసియస్ స్టేట్మెంట్లు ఉంటాయి. రివర్సబుల్, ఇది రివర్సబుల్. అదేవిధంగా ఇక్కడ వచ్చేసి క్లాసియస్ ఇన్ఈక్వాలిటీ అకార్డింగ్ టు లెస్ దెన్ Q బై T లెస్ దెన్ ఆర్ ఈక్వల్ టు 0, ఇది క్లాసియస్ ఇన్ఈక్వాలిటీ. dQ by T ఈక్వల్ 0, ఈకి వచ్చేసి రివర్సిబుల్ అనుకుంటా. ఒకసారి ఎంట్రోపీ ఫర్ రివర్సిబుల్ హీట్ ట్రాన్స్ఫర్ చేంజ్ ఎంట్రోపీ ఎస్టిమేటెడ్ dQ by dt. పర్ఫెక్ట్ గ్యాస్, ఆల్ 5 gases are under all conditions pressure and temperature. Boyle's law, PV constant, temperature BT and CV CP Commission of Police, CP Charles la Gale Class la V constant, Gale Class la volume constant, Joules law వచ్చేసి ఇంటర్నల్ ఎనర్జీ చేంజ్, ఇంటర్నల్ ఎనర్జీ du ఇంటిగ్రల్ dt. అదేవిధంగా జోగార్డ్స్ లా వచ్చేసి molecular weight of all perfect gas volume under same pressure temperature, equal volumes of all gases, same pressure and temperature, equal number of molecules. The molecules of NTP occupies volume 22.4 liters. P1 V1 by T1 equal P2 V2 by T2, P3 V3 by T3. PV is equal MRT. Molecular weight and its value of 29.27 kg Kelvin or 287 joule per kg Kelvin. Universal gas constant, molar constant 0 degrees Kelvin 8314 joule per kg mole Kelvin. General property of relation for a perfect gases 1 to CV dt. For CV is a function of T, 1 by J into K minus 1 P2 V2 minus P1 V1, C by CV C minus CV equal R by J. Irreversible part of an adiabatic process, log of P2 by P1 log of P1 by P2 minus 1 to CV dt R by J. Work done P1 V1 minus P2 V2 by JFN minus 1 MR T1 minus T2 JFN CV T1 minus T2. Heat transfer K minus N by K minus 1 into work done CV N minus K by N log A P2 by P1. N greater than K is the compression process, N less than K is the expansion process. Constant volume process is the constant value. Constant pressure, DH is thermal. Change in entropy, free expansion, thermal efficiency, Atkin cycle, Schilling cycle, Otto cycle consisting of two isentropic and two constant volume process. This is the Otto cycle process. A diesel cycle consists of two isentropic, one constant volume and one constant pressure. And a Joule and Brayton cycle is the consists of two isentropic and two constant pressure process by heat supply situation. Atkin cycle is the it consists of two adiabatic constant volume heat addition and constant pressure heat rejection. Still is it consists of two isothermal and two constant volume process. And then constant volume process. Unreversible cycles. It consists of two isothermal process and two reversible constant pressure process. Reversible efficiency is equal to the Carnot cycle. Erikson cycle efficiency is equal to Carnot cycle. Real cycle consists of two constant volume process, two adiabatic process, and one constant pressure process, heat supplied volume process. Vapor cycles next to vapor cycles in ideal represents vapor power cycles. Isothermal and two isothermal and two Rankine cycle, two isothermal and two isentropic process, one constant pressure process. ఈ విధంగా ఉంటుంది. Vapor turbine condenser control. Compression refrigeration is very small H5 minus H4 ఈ విధంగా compression cycle consists of two constant pressure process, an isentropic process and irreversible throttling process. Compression irrigation విధంగా ఉంటుంది. Mixture of gases, vapor, equal MRT, fuels, combustion fuels. Calorific value in the calorific value LCVHC weight of water into latent heat 588.76. Calorific value can be determined by a bomb calorimeter or Boyce gas calorimeter. Higher calorific value is the combustion cooled to 15 degrees centigrade. Lower calorific value 15 degrees centigrade 587.76. 1% moisture by 100 to change from composition of atmosphere value composition 50.19 oxygen and 8.0 nitrogen. Small quantity oxygen nitrogen 71 by volume, oxygen nitrogen 2377 by weight. Fixed boundaries determine the space working in the closed system, open system, in the system, across substance closed boundary on the system, and heated work also across the boundary. The system fixed mass or no heat or work cross boundary. Extensive properties is the intrinsic property is there. The properties value of entire system is equal to the parts of the software intensity individual properties. Thermal equilibrium, zero of thermal. The last is two bodies are in thermal equilibrium with the third body they are also thermal equilibrium. First law of thermodynamics, law heat and mechanical work are mutually convertible according to the law. The amount of mechanical work in the produce the Q equal W plus E. Second law the amount of mechanical energy it can obtain from the given quantity of heat or energy according to Clausius, according to the Kelvin-Planck statement laws. Boyle's law, Gay-Lucas law, same as the జనరల్ ఈక్వేషన్ అకార్డింగ్ టు బాయ్స్లో ఈ విధంగా ఉంటుంది. ఈ బాయ్స్లలో పీవీ అయితే ఉంటుంది, టెంపరేచర్ కాన్స్టెంట్ ఉంటుంది. P1V1 ఈక్వల్ టు P2V2. సౌండ్ అర్థం కాదు ఎందుకురా. చార్లెస్ లాలో వచ్చేసి ప్రెషరు కాన్స్టెంట్గా ఉంటుంది. T1V1 అంటే V1/T1 ఈక్వల్ టు V2/T2 ఇట్లా ఉంటుంది. అదేవిధంగా ఆల్ పర్ఫెక్ట్ గ్యాసెస్ చేంజెస్ ఇన్ వాల్యూమ్ బై 1/273 ఒరిజినల్ వాల్యూమ్ at 0 degrees centigrade for every 1 degree centigrade change in temperature when pressure remains constant ఉంటుంది. According to the above, Vt is equal to V0 plus 1/273, V0 equal to V0 of 273 plus T/273 equal to V0 into T/T0. 1/273 decreasing of by 1/273 of its original value for every 1 degree centigrade decrease the temperature. The temperature of minus 273 degrees centigrade becomes 0. Gay-Lucas law. Absolute pressure of a given mass of perfectly varies directly at its absolute temperature when the volume remains constant. Gay-Lucas lawలో వాల్యూమ్ కాన్స్టాంట్గా ఉంటుంది. P1/T1 P2/T2 ఈ విధంగా ఉంటుంది. అకార్డింగ్ టు బాయ్స్లో ఇట్లా ఈ విధంగా ఇట్లా ఇది ఇట్లా. అదేవిధంగా PV is equal to MRT. SI units of pressure expressed bar 1000 1 bar equal to 100 kN for a meter square. The gas constant or SI units in Newton meter for kg Kelvin or joule kg Kelvin kilo. 1 Newton meter equal 1 joule. The value of gas constant difference gases, the value of atmospheric air, it is a 287 joule for kg Kelvin or 0.287 kilojoule for kg Kelvin. PV is equal to MRT. Joules law, dE is equal to change internal energy కాబట్టి change internal energy of a particle directly proportional to the change in temperature. Joules law is equal to dE is equal to mc into dt. Avogadro's law. Equal volumes of all gases at same temperature and pressure contains equal number of molecules. ఈ విధంగా the molecular mass expressed in all gases normal temperature and pressure weight and NTP occupies the volume 22.4 liters. Universal gas constant, molar constant. Universal gas constant, molar constants. Gas is product of the gas constant molecular mass of gas equal to R equal to mR. SI units, the value of RU is taken as 8314 joule kg mole Kelvin or 8.314 kilojoule for kg mole Kelvin. The catalyst gas constant PV is equal to MRT. The heat supplied in the gas constant mass into specific constant volume temperature is mc into T2 minus T1. mcp into T2 minus T1. mcp into T2 minus T1. cp cp minus cv. Difference of two specific heat equal gas constant cp minus cv equal all. 2 adiabatic index reciprocal to Greek letter gamma equals cp minus cv. Gamma equal 1 plus r by cv. 1 plus r by cv. The value of air is 1.4. Expansion ratio, volume at the end of the expansion by volume at the beginning of the expansion. Compression ratio, volume at the beginning of the compression by volume of the end of the compression. Polytropic process. The polytropic process, also known as the general expansion and compression of gases, given the relation PV over N. The heat observed or rejected during polytropic process, Q is equal to gamma minus N by gamma. The work done equal to gamma minus N by gamma minus 1 into P1 V1 minus P2 V2 by N minus 1. Gamma minus N by gamma minus 1 into MCV T2 minus T2. The polytropic index given by N equal to log of P2 by P1 by log of V1 by V2. Entropy dq equal TdS. It may noted that the 0 degrees of assuming have zero entropy, change in entropy are knocked from the temperature. A cycle which requires 4 piston strokes and 2 complete revolutions of the crank is known as a 4-stroke cycle. Which requires only 2 piston stroke and 1 revolution, the crank is known as a 2-stroke cycle. The air is emitted by working substance inside the engine cylinder is called as an air cycle, reversible cycle and irreversible cycle. Throttling is an irreversible process. Efficiency of cycle. Efficiency work done by heat supplied. Heat supply heat treated by heat supplied. Increasing internal energy, MR of T1 minus T2 by gamma minus 1. T1 minus T2 by T1. Stirling cycle. Efficiency of Stirling cycle 1 minus T2 by T1. Ericsson cycle. Efficiency of Ericsson cycle the same as that of Carnot cycle. Minus 1 minus T1 by T2. Lowest temperature by highest temperature. Joule cycle. 1 minus T3 minus T1 T4 by T1 T2 minus T1. 1 by R of gamma minus 1. 1 minus 1 by gamma R of gamma minus 1. 1 by R of gamma minus 1. 1 by 1 minus 1 by R of gamma minus 1. Compression. The efficiency in the see from the equation, the efficiency of Otto cycle depends on compression ratio. The efficiency increases with the compression ratio but increase will be at the value of 7 also. Compression rate. Total cylinder volume by clearance volume plus stroke volume by clearance volume by stroke volume by gamma minus 1. Compression ratio V4 by V1, cutoff ratio V2 by V1. The efficiency of ideal cycle is lower than that of Otto cycle for the same compression ratio. The disease cycle efficiency increases with decreasing cutoff, approaches maximum. The cutoff is 0. Clearance value, stroke value by gamma minus 1. Dual combustion cycle. Otto cycle rho equal to 1, for diesel cycle alpha is equal to 1. The efficiency of dual combustion cycle is greater than diesel cycle is less than Otto cycle. Same combustion ratio. Actuation network output by work done by the turbine. By compressing a two-stage interval between two T. Wood 197 kJ per kg, peat 2300 kJ per kg. Lignite brown coal is the 25,000 kJ per kg, bitmarsh coal is the 33,500 kJ per kg. Anthracite coal is the 6,000 kJ per kg Kelvin. Wood is the 280 degrees. Coke is the 40 to 48 hours. The carbonization of coal is carried 500 to 700. The resulting coke is called lower temperature coke. It is pure coke is produced. Carbonization of coal is 900 to 1100 known as hot coke. Petrol gas line distilled by temperature from 65 to 220 degrees centigrade. Kerosene or paraffin oil is the 220 degrees to 345 degrees centigrade. Heavy fuel oils is the 345 to 470 degrees centigrade. Mondi gas 650 coal is about 650 degrees centigrade. The engines of calorific value is about 5850 kilojoule per meter cube. Coke over gas, coke oven gas is the calorific value varies from 14,500 to 18,500 kilojoule per meter cube used for industrial heating and power generation. Calorific values of fuels CV ఈ విధంగా ఉంటుంది. The calorific value of solid and liquid fuels it may be found the bomb calorimeter. The calorific value of gas and liquid fuel found by using any gas golden black boys gas calorimeter, Jenkins gas calorimeter. LCV HCV minus LCV is equal to HCV minus heat of steam formed during combustion. Mass of carbon per kg of liquid gas 3/11 CO2 plus 3/7 CO. 100/23 mass of oxygen gas. Mass of air. Thank you very much.